Thanks everybody for taking the time to be here today. I just spent about a half an hour talking with a few of you about our DevOps orchestration and automation platform, Electric Flow, which helps people really understand that value stream, automate out a lot of the manual, error-prone work that's there, and get you to a point where really the only time you need to slow down is when you're asking for someone to approve something. And what we find with a lot of our customers is that simply automating sometimes isn't enough. You can't go fast enough just by automating to be able to keep up with the demands of continuous delivery, continuous deployment, even just CI, continuous integration. And so that's what we're going to be talking about. And so I'm going to just put this slide up here and ask who in the audience agrees with this statement. Does anyone disagree? No one would ever disagree with this statement, right? So slow builds and tests suck. Slow anything sucks. Anything that takes time, too much time is painful. Martin Fowler talks about the 10-minute CI cycle, right? There's a reason that he talks about that, is because developers hate waiting. We have customers, one of our customers over in China, who actually called compile time was actually, they just renamed it to coffee time, right? Because that's when they were able to go and they couldn't really do anything else. And so they went off and they just had coffee. And so it's the #1 programmer excuse for legitimately slacking off. This is another great cartoon by XKCD. Love that guy. So that building and testing of what you put into that release pipeline is sort of the tip of the agile spear. That's what gets you able to do CI and get that whole process moving at a nice clip. What ends up happening, however, as your application source code grows, if you're doing test-driven development, you're adding more tests. You want to make sure that you're doing static analysis. You want to make sure that you've got code coverage, right? These things that you add, the number of platforms that you need to build for, these things start to slow down your process. So what a lot of times people will do is they'll move things out of the CI process. And we all know what happens when you push work to the right. It becomes much more expensive if you find a problem. And so people are always trying to shift work left, right? Do that work earlier. Jez Humble has got a great quote about that. If it's painful, do it sooner, right? And get really good at it. And so the speed that we're talking about is really essential for these teams to get the feedback that they need quickly so that they can act on it and improve that code. Again, back to the evolution, if you will, of that software. You need feedback, right? If you put a pie in the oven and you bake it and you don't try it for 4 days, you really don't know if that's a good recipe or not. You probably shouldn't be basing all your subsequent pies on that recipe. It's good to take a bite of it right after it comes out of the oven. Of course, you should probably cool it down first or you're going to scald the inside of your mouth. So what is your pathway to production? You guys, if you were in the last session, you've seen this before, but I'm going to go through it again. If it follows a pretty typical pattern, right? You're building your software, you're testing it, and then you're releasing it into production. If you can automate out some of those manual handoffs, if you can sort of optimize inside of the silo, you can accelerate that process. But once you've done that, once you've large grain parallelization, if you can do multiple types of tests at once, if you have eliminated all those manual handoffs, and you think you've got everything pretty much nailed, you've got the fastest possible pipeline you can, at that point, what do? How do you accelerate that process? Well, you want to accelerate the process in testing and in building that software so that more of your time is spent doing things like functional testing, UAT testing, or spending less time in general doing the entire cycle, right? So you get better quality software and you get it faster. So how do you go about doing things more quickly? Well, if you think back to Tom Sawyer, what did Tom Sawyer do when he wanted to paint the fence, right? He actually figured out a way to make it so the other kids wanted to help him paint the fence. He sold that as a benefit. But what he really did is he parallelized that work, right? He made that work that would have been 5 hours by one guy, it's actually 1 hour by 5 guys, right? That's a pretty logical thing to try and do. The problem, of course, is dependency management. Tom Sawyer, he didn't have to worry about somebody doing a base coat and then a top coat. He was whitewashing the fence. We work in a much more complex sort of environment, where if you try and do something before something else, if you don't do it in the right order, that can cause some serious problems, right? So the concept of parking a car in a garage, there are 3 pretty simple steps involved. The first one is open the garage. Second one is close the garage. And the third one is drive the car in. But the order of those things really matters, and I said it in the wrong order, right? You don't want to close the garage until after the car's inside. As your application code base shrinks and grows and moves around, the dependencies that you have are also going to move around. The time that it takes for a certain component to be built and be available for somebody else to use is going to change all the time. And so teams will spend hours and hours, and they have whole teams of folks who are focused on optimizing that makefile, optimizing the dependency chain. It's kind of a pain, right? So you have to make sure that you've got that dependency management covered. And then to the extent that you're able to, you want to eliminate rework. My favorite kind of work is work that I don't have to do. Work that I've already done, that I know is good, and that I don't have to do again. That's why people like version control and artifact repositories. Why redo work? And so ElectricAccelerator is a product that we have. It works really, really well with our Electric Flow product. And what it does is it parallelizes and distributes this work across any number of shared cloud or local CPUs that you have, right? And how does it work? Well, it provides quite a bit of functionality for teams to be able to run both builds and tests in a way that is dependency aware. We talked about that. Priority aware, so if it's a production build that has to be out right now, it can get a larger majority of those resources that are working on those jobs. Workload aware, so if it's a job for a team that's actually paying money for this shared pool versus a team that's just sort of taking advantage of it, you can set up priorities and workload affinities for those 2 different groups. And of course, infrastructure aware, right? Making sure that it's not overloading a system to the point where you're giving it too much work that it's actually going to slow down the health of that system. And of course, it does this on top of either your multi-core desktops. I'll talk a little bit about how we do that later. Your multi-core servers that you have in a pool, or else a cloud of dynamically instantiated machines. So there's an example, and actually the graphic here is a little messed up, but what you're seeing here on the left is a GMake build with the -J8, so you're using 8 cores to do this build. And you can see how slow that line is moving. On the right-hand side, I'm actually going to fix this slide because I think that I want to make sure that you guys are seeing that. I don't know what that circle-y thing is, but I'm going to kill it because I don't want to see it anymore. On the right-hand side, what you've got is an ElectricAccelerator doing that same exact build. And look at how much faster it's going. Which one would you want to wait for if you're a developer and had just checked in a bunch of work? Which one would be the one that you would want? I would certainly want the one that's doing 32 builds per minute, not the one that's doing 1.9 builds per minute, right? And we do that through that massive parallelization that you can also do with GMake, but again, the dependency management problem that we talked about, we take care of that 100%. We guarantee the accuracy, and we actually learn every time we run your job, we learn the right order that it needs to be executed in to make sure that it's accurate. It's got actionable visualization, so you can actually see where the longest serial chain is in your test group or your build group, so that you can go in, if you can, and componentize it out so that it can be blasted across more resources in a very easy manner. And then, of course, efficient resource utilization, same as we talked about with Electric Flow. If you've got a build farm here or a test farm over in India, and it's only being used for 12 hours out of a 24-hour day, you can pool those resources together and give folks anywhere in the world access to using those CPUs in a very scalable, very efficient manner. And we find our customers really can take advantage of a lot of hardware savings, a lot of power savings by using ElectricAccelerator. An example of a customer who did that is GE Healthcare. They were able to take a build from 11 hours down to 20 minutes with the number of distributed systems that they had running that job. So if you think about it from a okay, I need to do a build, and I'm going to start the clock now, I'm going to walk away, and I won't see any results until tomorrow, basically. This changes the game for them so that now they can do multiple of these builds during a workday, integrate this code more quickly, more effectively, and do that testing more quickly and effectively as well. So the core value that we've talked about from ElectricAccelerator, of course, is that going faster due to parallelization, that 100% correctness because of the automatic dependency detection that we have, and of course that efficient use of shared infrastructure. One of the features that we've recently added, which is analogous to Ccache, which is some technology that you guys may have played with, it's called job cache, and what it does is it helps you go even faster by eliminating any of that rework. It's my favorite kind of work to do. It's work that I don't have to do, right? It applies that same 100% correctness to the caching technology, which is something that Ccache does not do. And it gives you the flexibility now, instead of just being more efficient with your infrastructure, the next slide I'm going to show you will actually show you how you can use less resources. A customer of ours, EMC, had filled up their data center with servers. They wanted to buy more capacity of ElectricAccelerator, but they didn't have any more servers that they could put in that data center. It was full. They had no more power, couldn't do any more cooling, no more space in their racks. So what we did is we came out with Job Cache, which allowed them to just say, hey, guess what? This work's already been done. The code hasn't been changed. We have a fingerprint, basically, MD5 hash of exactly what that component looks like when it's built. So we don't have to build that one again. And what it allows you to do is you can see this curve here. This is actually 16 cores worth of this top line here. You can't really see my pointer. The top line there, it's running ElectricAccelerator on 16 cores. So the actual amount of time of doing this serially would be somewhere over here, I think, is about how long that job would be if it was being run without ElectricAccelerator, if we're following that graph. Now, what you'll notice is it gets pretty short, pretty quick as you move up to 64 and higher, 112 cores. Again, we can parallelize this thing out across as many cores as you have very, very dependably and without any accuracy problems. The interesting thing to note here is that without Job Cache, this is how fast you can go with 64 cores. It's actually faster to go 16 cores with Job Cache. So you have cut the amount of hardware you need to go as fast as you want to by 4x, which is pretty amazing, right? And so EMC is taking advantage of that and basically getting 4x the amount of capacity out of their existing infrastructure, which is pretty amazing. Another example from a test perspective. Anybody here have slow testing? Is that a problem for anybody? Yeah. This is a use case that we see an awful lot of because the builds nowadays for a lot of web type companies don't exist, right? This is all not compiled stuff that you're running. But Selenium tests, static analysis tests, those things have to be run and they take a lot of time. So here's a use case where we're doing boost, code coverage, and bullseye. And we were able to get from 7 minutes and 30 seconds down to 39 seconds. It's 11.5 times faster, right? Another use case, Selenium. These browser tests, they stopped running them because they just took too long. Does that sound like a smart idea? Not really, right? So what this allows them to do, 61 times faster, is run those tests earlier in the cycle. You could get it down to 27 seconds, down from 27 minutes. These are not small gains that we're talking about here. And this is, again, after it's been automated to the point where we think it's as fast as we can go. And then all of a sudden, 61 times faster for one of the slowest parts of that process. So I've talked a lot about what it does, but how can we actually prove that to you to make sure that it's working in your environments, right? And so similarly to Electric Flow, that has a community edition, ElectricAccelerator, we have a community edition as well called Huddle. And it allows you, instead of requiring you to have an enterprise cluster manager, or ElectricAccelerator cluster manager, you have a user in your huddle that sort of takes the role of being that cluster manager. And then you share it with your buddies. You share this tool with your buddies. And anyone who joins that huddle can give their CPU cycles to the huddle. So if you need to run testing and you've got 10 engineers with 8 core rigs, you've got 80 cores to play with. Because we're not distributing this work to a machine. We're distributing work directly to a core, which gives you a lot more scalability than you would if you just 10 machines versus 80 cores, right? And of course, it plugs right into the tools and the scripts that you're already using for the most part, for the Selenium tests, for pretty much for anything that you do. If it can be broken down into atomic units of work, it can be accelerated, right? The screens for ElectricAccelerator Huddle give you visibility into who's participating, what jobs are being run, the progress of those jobs, and of course the usage metrics for that huddle. So you understand over time, how am I using this system? Where are the slow spots? Who's helping the most out of my team, right? So it's good, sort of a social, collaborative user interface to help people feel involved in that part of the process. And so before I open it up to questions, basically the summary here is that ElectricAccelerator helps you to safely parallelize those jobs so that your builds and tests are just insanely fast. 61 times faster is, I think, the highest acceleration that I've seen. I would challenge you to find better, and wouldn't you love it if you could, right? Better infrastructure utilization, we talked a little bit about that already. It's a learning system, so it ensures correctness. It's always learning. Every time you make any change to whatever it's either building or testing, it's going to bake those dependencies into its chain, right? So it knows. And that can help you increase that developer productivity to get rid of that coffee time, right? A couple of examples of customers who are using our products to accelerate their continuous integration cycles. And then, of course, same thing goes here as before. Going fast is really good. Tools are great. But more important than tools is having a community of people that you can learn from, that you can work with, to understand what a best practice or a good practice is and what a bad practice is, so you can find those patterns. So Electric Cloud, instead of just trying to sell tools to people, we invest pretty heavily in the community. DevOps Enterprise Summit, we've underwritten this with Gene Kim and IT Revolution. It does give us an opportunity to speak with people about products, but really what it helps us do is help make folks comfortable with the concept of DevOps, with the concepts of continuous delivery, because we think that's going to be good for the earth. We want to help the world deliver better software. It's good for all of our lives to have this technology work better and have more quality. And so we have this open discussion, because DOES can only happen once a year. We have this open forum called C9D9, which is continuous discussions, where we invite practitioners to come and join us. I think we're on like episode 26. We do it every other week. And so we have a number of random topics that we discuss. We would love it if you'd listen in. The next one is on Docker and containers in your CD pipeline. We'd love it if you'd listen in. We'd also love it if you would join us as a speaker. If you're interested, just shoot us a note. We'll send you a list of the upcoming topics. And if it's something where you feel like you have something to say, an opinion or a point of view, we would love to hear it, and so would the community. So with that, I'm going to ask if there are any questions.
Are there any specific types of tests that that Accelerator speeds up?
That's a great question. So the question is, are there any specific types of tests that ElectricAccelerator helps to speed up? The answer, I've got a bunch of them written on the screen right here. So you're looking at Selenium, any of the static analysis tools that are out there, code coverage, Boost. But again, any work that can be broken down into an atomic sort of command line callable thing is very easily accelerated. Even things that can't be broken down into command line callable things, we have APIs and a tool called Electrify that can actually get into the process and distribute work within a process, which takes a little bit more work to set up, but the results taste just as good. Excellent. All right. Thank you all for joining, and I look forward to seeing you guys download and start getting Huddle working in your environment. Thank you.